Hey, morning. Morning.
Hello.
Just getting ready here, just a second. Okay, what questions do y'all have?
Number 10.
Number 10, okay. Let me get to it.
I don't really understand like Morse code in general. Like I didn't really understand what that meant.
Oh yeah, Morse code's a tough one. Okay, let me get there. Okay, so with Morse code, there's I don't have the actual Morse code here, but I'm just gonna make up stuff right now.
Okay.
Just so you have a sense of so an A might be a dot. A B might be like dash dot. A C might be like dash dash. A D might be dash. An E might be dot dot. Now we've almost run out of letters, so that'd be like I could do dot dash. I've run out of all 1 and 2 character letters already. Does it make sense?
Mm-hmm.
Like G could be dot dot dot. It'd have to be 3 characters at this point because I've run
Yeah.
out of there's only so many 1 or 2 character letters. So then you have 3 character letters, there's 4 character letters. The characters are like the dots and dashes, right? So you could have a 1, a 2, a 3, a 4 character letter. Typically what they do is these 1 dash, 1 dot, or 1 dash, the more common letters are going to get the shorter number of characters, if that makes sense.
Mm-hmm.
Like a Z or an X might be like a 4 character letter because it's not as common, maybe. Okay, so let's look at this. By sequence of dots and dashes, how many letters can be represented by Morse code if 3 or fewer symbols are used? So let's talk about 1 character letters first. So you tell me, how many 1 character letters are there?
2.
2, right? The only options there are dot or dash. Those are the only options. So there are 2. How many 2 character letters are there?
4?
Right? So
No. Is it? Oh, okay.
and the way you could do that is slot method, right? 2 times 2
Right.
is 4. You could actually write them out as well. Dot dot, dash dash, dot dash,
Okay.
dash dot. Those are all the 4 characters.
Mm-hmm.
Okay, how many 3 character letters? 3 character letters.
9.
Ooh, I don't agree.
Okay. Oh,
Do slot method if you're having trouble.
so 27?
Oh no, how many options for each letter?
3? No, it's still 2. Okay. It's still
2
2.
times 2 times 2 is
Okay.
8. So
Okay.
8 3 character letters. You could write them out. Dot dot dot, dot dot dash dot dash dot dash dot dot dash dash dot dash dot dash dot dash 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 dash. Is that all of them? 6, 7. I think that's all 8 of them. That makes sense.
Mhm.
So there's a total of 2, 4, and 8. That's what,
So
16? So there are 16. There are 16 different letters that could be used. How many? Just for fun, how many 4-character letters could there be?
16.
16. 2 times 2 times 2 times 2. So it'd be 16 of those. So really, that would be enough. That's 32 letters total if I had 4 characters. So the whole alphabet can be represented in 4 characters or less. And that's actually true. That's, again, I don't remember the actual Morse code, but if you're ever in a tough situation where you have to tap on a pipe, it's the best thing to do, to get a message out. Other questions?
Number 6.
Okay. Group students determines they can stand in a row for the first picture in 120 different ways. Okay, so this is kind of a tough question. Let me ask it in reverse. Let me say, what if you had 5 people? What if you had 3 people? How many different orders could you stand in? Like if the question was you have 3 people, how many different orders could you stand in? How do you figure that out?
I mean, you could do the slot method.
Right,
Right.
you would say 3 times 2 times 1, which is 6. Or would you agree this? You could say 3 factorial as a shortcut, which is 6.
Okay.
Does that make sense?
Yes.
Okay, so do it in reverse. In other words, this question is basically saying how many students are in the class? X factorial equals 120. Does that kind of make sense?
Okay.
Now, we don't have a way algebraically. We might be able to use calculus or something to do this, but we don't really have a way to do that algebraically. So I really think I would do it this way, like 6 factorial. Nope, that's way too much. 5 factorial. Oh, that's it. Like just start guessing and checking. Like there's only a few numbers you would have to check. Does that kind of make sense?
Okay.
I mean, it's a tough problem, but there's really algebraically no way for us to solve this equation that we know of because it's a pretty complicated question, actually. Because it's like a series, it's like a sequence. It's like basically saying x times x minus 1 times x minus 2 times, but we don't know how many of these things that there are, if that kind of makes sense. So it's a very tough algebraic. So it's guess and check at this point is the best way to think it through.
Okay. And then could you also do on part 4, 2C?
Sure. Okay, coin is flipped 5 times. The first heads is on the 3rd flip. Okay, so you're flipping a coin 5 times. 1, 2, 3, 4, 5. You want to get heads. So I want to get tails on this one, tails on this one, tails on this one, tails on this one, and then I want to get a heads. Does that make sense?
Wait, don't you want it on the 3rd flip?
Sorry. If you read it carefully, it actually says the 3rd flip. Thank you. So I think that's what you want, right?
Mm-hmm.
Okay, so I think this would just be what's the probability in tails in the first flip? I want to get tails in the first flip.
So half.
1/2. And unlike like sometimes grabbing a ball from a bag, it changes the probabilities, but I think these are independent events. So on the second flip, I want to get a tails also. What's the probability?
Half.
Yeah, I don't think it changes. And then what's probably on the third flip, I get a heads.
Half. Okay.
So I think is the answer 1/8.
Yes.
I think that's how. The other way to do this, and really, it's not a bad way to do this. If you're struggling, if that doesn't make sense, I would definitely write out. You've got 3 flips. You can actually write out every possible combination. So you could go heads, heads, heads. Are you following me? Heads, heads, tails,
Hmm.
heads, tails, heads, and write out. There's only 8 possibilities, right? So you could write them all out. And then when you get to, one of them is going to be tails, tails, heads. You could circle that one out of the 8 that you list here. Does that kind of make sense?
Hmm. Thank you.
Whenever you're struggling, just write out the sample space, especially when it's a small number of, 8 is not that many to write out. And there's 8 because it's 2 times 2 times 2. There's going to be 8 possible. All probability, once you start thinking about it, there's other ways to get to the right answer. If this slot method doesn't make sense in that case. Like, in fact, I think like at least 3 heads or at least 2 heads, I would write out the sample space. If this said at least 2 heads, I would write out the sample space and just circle the ones that have at least 2 heads in them. Does that kind of make sense?
Yes, thank you.
Again, the sample space is the list of all the possible combinations, because I might ask that question. Sometimes students, I had to ask that on a quiz, but I want to make sure sample space is the list of all possible combinations. Other questions?
Can you go over distinguishable permutations and like numbers 8 and 9?
Sure.
Because I just like don't know when to use it.
Sure. Yeah, I feel like that's half the battle with just probability in general. Like, when do you use what method? The calculator does all the work for you. It's just a matter of, well, how do I know to use this method then? Like, it's kind of a learn. You have to kind of do some problems and eventually you start getting it sometimes. Okay, so let's ask a somewhat simpler question. If we had like the word, let me see. It's like, this is Cinco de Mayo. So if the word was Mayo, how many different ways could I reorder the letters Mayo, M-A-Y-O? That's a straightforward question. It's very straightforward. It would be, you could do 4 things like this. How many options for the first letter would I have?
4.
4. How many for the second letter?
4.
No.
Right. Oh, 3. Right. Sorry.
If I've chosen the first letter, like there's one less choice for each letter. Or the easy way of doing that is just 4 factorial, and then you got it, whatever that is. 4 times 3 times 24, right? So a very straightforward question. If all the letters are different, that's the key in that one. Hopefully you recognize on this one, there are some overlaps. Like, do you see how there's 2 M's? There are 2 A's. Is there any other repeats?
T.
And 2 T's, right? So there are 3 letters that are repeated. So because there's repeated letters, this is not a straightforward problem like this one is. Like, straightforward problems, piece of cake, you got it. This one, kind of like on the extra credit of one of the quizzes, it was St. Mary's, had some repeat letters. So anytime you have some repeating there, because, and this is the reason for this, like if I reordered these letters, and let's just pretend I did it this way. So if I did M, I'm just telling you about the reason before I show you the calculations. M, A, T, H, E, M, A, T, or sorry, I got the M's, A, T, I, C, S. Okay, so I reordered it that way, and now I'm going to reorder it this way. Those look awfully similar to me, but I don't know if you noticed, but I took the first M and I switched it with the second M. Did you notice that? Could you tell?
No.
Was that a distinguishable permutation or an indistinguishable permutation? Like, I can't distinguish between these two. These two look exactly the same to me. How am I supposed to know that you switched the M's, or I switched the M's there in the first 2 letters? can you really tell the difference between those two?
No.
Like I can't tell the difference either. So I count that as one permutation, not two. So if we just did 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, if I just did 11 factorial for this, there would be a number of combination where actually I'm double counting the same, like I would be double counting that, for example. Does that kind of make sense?
Mm-hmm.
11 factorial is going to give me too much. So what you have to do is you go 11 factorial up in the numerator, and then you do the n1 factorial. And so if there are combinations like m and m, I'm going to put 2, that represents the m's there. The a's are 2 factorial because there's 2 of them. There are 2 t's, so that would be 2 factorial. And then the rest of these, like the h and the e and the I and the C and the S are all 1 factorial. Well, I could list 1 factorial, but all these 1 factorials if I want to, but you see, like, that's kind of silly because 1 factorial is just 1. Does that make sense?
Mm-hmm.
So then you just really have to type in this in your calculator.
Okay, thank you.
And this one, now let's just see this. How many ways can 5 red balls and 2 white balls and 7 blue balls be arranged in a row? So again, so if I'm ordering balls, if I put red, red, white, you know, etc., and then I put red, red, white, and the same, etc. here. That makes sense?
Mm-hmm.
Those two are the same combinations. How do you know, oh, I switched the R and the R? How would you possibly know that? So when you have repeating things that look exactly the same, but I put them in different orders, and I would recount those, so I can't really do that. So I have 5, 2, and 7. So that's like, what, 9 and 5, 14. So that's 14 factorial up top. That makes sense, right?
Mm-hmm.
But if I do 14 factorial, I'm going to have a bunch of like repeats here. I don't know how many, but I have a bunch. So in the denominator, if I have a group of the same thing, like I have 5 red balls, so I have to put 5 factorial. I have 2 white balls, so I have to put 2 factorial. And I have 7 blue balls. And so anything that, you know, the order makes a difference, but they look the exact same, whether it be balls or in this case letters or whatever, it's going to be distinguishable permutations. And so like it's just a kind of a learned art as you kind of like see enough problems. If you think about it close enough, you'll see like, oh yeah, those are the same things. I don't want to double count those because they're of that repeat. Whereas this, there's no double counting with Mayo, right? I mean, you can actually write out all 24 different ways of writing Mayo in different orders, but there's no like MM or AA because there's only one letter's used once. So the repeating is the giveaway there.
Okay, thank you.
Sure. Other questions?
Can you do number 4 and 19?
Sure. Okay, so 15 flavors of ice cream, banana split with 4 scoops. Each scoop would be a different flavor. How many banana splits? So I think the key question here is order important or not? Like, are we going to do NCR or NPR?
Well, I looked at the back and you did NCR, but I was just confused why you can't use slot method.
Okay, so NCR is a method, and then NPR is a method, and slot method is the same as NPR. Those are the same things.
Okay.
So is order important here? Do you think, before you answer the NPR or whatever, is order important or not?
No. I just saw the word ordered and thought maybe it was.
Yeah, I mean, sometimes can be ordered. Yeah, ordered in that case means like place an order in a fast food place. Does that make sense? Like,
Oh. Okay.
how many different combinations can you order? But if you think about, like, you have a banana split bowl and you have like chocolate, vanilla, strawberry, and pistachio or something, you've got 4 flavors, right? So if you've got those 4 flavors, does it really matter if the person puts chocolate and then vanilla and then, you know, strawberry and then pistachio, or maybe switches the order like it's still the same sundae if you have those same scoops in there.
Okay. Can you give
So-
an example of where you would like need to use permutation?
So, so let me think of one. So, I'm trying to think of a food example for some reason, but I'm struggling with that because like pizza toppings would be orders not important.
Because I know in our notes that we use slot method for like a sandwich combination, so that's why I was
Okay, so that's a different kind of question. So with sandwiches combination, like if I have 3 breads and 4 veggies and 2 kinds of meats,
Mhm.
how many different sandwiches if I get 1 of each? And I just multiplied those, right?
Yes.
Because that question is not how many different orders can you get, it's how many different sandwiches can be ordered. It's like how many different combinations. That's called the counting principle, where you're going to multiply. So 3 times 4 times 2 is 24. And you get the total number of sandwiches that can be ordered. This is not this is asking like, there's only one, it's just a different kind of question. I don't know how to, like that's a how many combinations. It's a very straightforward how many combinations. There's no repeating of anything. There's only 1 bread, 1 veggie, 1 meat. There's 3 categories and you get 1 of each. This is like you've got 4 scoops of ice cream. So then you get the same thing 4 times. Like for some reason, I'm tending to think, so how many different orders? So order would be something like this. So there are 4 runners in a race. How many different orders can they finish in? In this case, first place, second place, third place, and fourth place are a big difference. Like when you run a race, it's a big difference whether you run. So order matters. So this would be 4 factorial. This would be slot method,
Okay.
right? 4 times 3 times 2 times 1. So if the order matters, like how many different ways can you line up in a classroom? If you have 15 people, can you line up to go outside the door on a fire drill? It would be 15 factorial, which would be a huge number of ways of doing that. That's a gigantic number. So it just matters if it's, I don't know, if order is important with that or not. What was the other one? 19, you said?
Yes.
Okay. Okay, a bag contains 8 white balls, 8 white balls, and 2 black ones. John picks 2 balls at random from the bag, and he wins $5 if he does not pick a black ball. So this is an expected value question, I believe, right? We're trying to find, I think the instructions probably say something like expected value, find the expected value. So you want to do a chart, like with amount and probability here. And either he wins, it looks like, or he loses. Looks like those are the 2 possibilities here. So how much does he win? First of all, if he wins, how much money?
$5.
$5, right? So this is $5. How much does he lose if he doesn't pick right?
$0.
Yeah, I don't think he loses anything. He just loses. So this looks like a fun game to play. I mean, you can only win, you can't lose. So that occasionally happens. It's not very common. So probability of winning, how often? So he does not want to pick a black ball. So off to the side, let's figure that out. So that would be, he wants to pick, I guess he wants to pick a white ball and then another white ball. Do you agree with that?
Yes.
Like he wants to pick one of each. So what's the probability to pick a white ball in the first pick?
What? 8 white balls and 2 black balls.
Yeah.
Oh, 8 out of 10.
8 out of 10. What about on the second pick? He wants to pick another white.
7 out of 10.
7 out of what?
Or 9.
7 out of 9, because these are not independent picks. So once he picks out the first ball, he doesn't replace the ball, so that the probabilities all change.
Okay.
And so then you just multiply that out, whatever that is, that's the probability of winning. So that would be like 56
Oh.
over 90, which
Mhm.
is 28 over 45. I'm going to just say it that way. So probability of winning is 28 out of 40. That's actually a pretty good probability of winning. That's not bad. Win roughly half the time. So what's the probability of losing? Was that 17? Does that look right?
Mm.
17 out of 45. Those two have to add up to 100%. So now you're not quite done with the problem. So with the expected value, you've got to take the amount times the probability. So 5 times 28 over 45 plus 0 times 17 over 45. And then you want to get your calculator out. So it'd be 5 times 28 divided by 45. And I'm not even going to do plus 0 times something because that's 0. So you win on average, you win $3.11 every time you play this game.
Okay.
It kind of makes sense. So you're actually like, this is an amazing game. I want to play this game all day long. I would be super rich. It would be amazing. Like Chick-fil-A one time had a game where you could just walk in and ask for like a free scratch off kind of a like game piece, kind of like McDonald's used to have that Monopoly. Anyway, like that's a case where you could just ask, no purchase necessary. You could ask for one and they give you a game piece and you have a chance of winning. So that's a similar kind of game, although this, you didn't usually win $3 every time you played. But I'm trying to think of like an equivalent. Sometimes fast food places will have contests where they actually give away like a game piece type of thing where you have a chance of winning and you really can't lose for playing. So there is something like that. I had a friend on my tennis team in college, and his dad owned a McDonald's, and he gave us shoebox fulls of McDonald's game pieces, and we would just open them until we won free prizes, and we would go there and eat. It was amazing. Like, it was a good time of my life right then. Okay. Other questions?
On number 19, on the same one, on the review, like the answers, it had the probability as like a NCR.
Ooh,
So, but you got the same answer.
we got the same answer. I think that's because it's the same thing repeated. I like the NCR way better. So I will have to say that. When it's repeated, I think, probability is weird. You can figure things out different ways sometimes. I know that sounds strange, but it's one of those topics where sometimes there's multiple ways of doing things. I like the NCR. I would say this, the NCR way of doing that is safer. I like it better. If there's such a thing as a safer way of doing something.
Okay.
Because order wasn't really important. It was an easier way to do it and a safer way of doing it. If there were more options, I definitely would have gone NCR every time there.
Okay.
But it was somewhat straightforward, and you could just do it that way if you want.
Can you do number 14?
Sure. Okay, card is picked from a random deck, what is probably as a red card or 10. So I think the best way to think this one through is with a Venn diagram. So you've got red cards and you got 10s. Are there any repeated, are there any cards that are both red cards that are over in the overlap there that are both red and 10s?
Yeah, there are 2.
There are 2. So I'm gonna put 2 in the in-between spot. How many red cards are there that are not 10s?
24.
24, because there's 26 total red cards. Because there's 2 suits. Half the cards, half of the deck is red, but 2 of them are actually 10s. How many 10s are 10s but not red?
2.
2. So this is really the best way of thinking this through. So then you've got a total of 24, 26, 28. 28 out of 52 would be, I mean, you simplify that, but that's the answer. The other way of doing this is to actually use the formula. So some people really prefer the formula way of doing this. So the probability of A plus the probability of B minus the probability of A and B. This is for an OR statement. This is the formula for an OR statement. So this is saying like red card or a 10. This is the formula you could use. So in this case, probably a red is your first event. So probably a red is 26 out of 52. There are 26 red cards. Plus probably a 10. There are 4 10s. Sorry, out of 52. Minus probably both those happening. There are 2 cards that are both red and 10. So 2 out of 52. So what this is doing is saying, when I get this 26 here, that's really adding up those 2. That kind of makes sense. When I get this 4, that's really adding up those 2. Can you tell that I double counted this this middle number here? That's where that comes from. So I'm subtracting, I can't count that 2 twice. So you subtract that to get 28 out of 52. And of course that simplifies to be, what, 14 out of 26 or 7 out of 13. So you simplify your answer, but you can get a formula way by subtracting the overlap, or I prefer to just draw it with a Venn diagram and add up that total. Anytime there's going to be an overlap with an OR statement. Now, if they're mutually exclusive events, you can just add them. Does it make sense? If there's no overlap between the 2, what's the probability of getting a red card or a spade? Is there any overlap between red cards and spades?
No.
No. So you could just do 26 out of 52 plus 13 out of 52. And you could subtract the overlap, but the overlap is 0. Does that make sense? So sometimes if there's no overlap, you don't have to worry about the fancy formula. Mutually exclusive, you just add them up.
Okay.
Other questions?
Can you do number 1 and 3 on quiz 14.5?
So yeah, let me get that. Okay, let's do 1 first. 400,000 is protected by 4-letter password. You pay $1 to have a guess. It's 4-letter. If you guess correctly, you win the 400,000. And does the quiz say what am I trying to find? I'm just trying the expected value, right? So I'm trying to find expected value. So to me, I always usually set up kind of a basic kind of a chart here: amount, probability. I see only 2 things. It looks like you either are a huge big winner or you're a little bit of a loser.
Mm.
Okay, so what do you win if you win? How much money do you win?
399,000.
Very good. 399,000 and I'm assuming you meant 999.
Oh, yes, that's what I should have put.
And then lose, how much do you lose if you lose?
$1.
$1, because the cost to play was $1. That's why we had to subtract $1 from the 400,000. How many different, this is a good case that we've got to figure out how many different combinations. If you got 4 letters for password, how many different combinations are there going to be?
Why don't you use permutation though? Because I thought passwords have to be like there's a certain order to them. That's why I was confused. Like if you change the letters around, it's a different password.
Right, it is. So I'm using slot method, which is permutations.
Oh, okay.
We can try to do it we'll try to do it my way, slot method, and see if we get the same answer the other way. So slot method, you go 26 times 26 times 26 times 26, right? Type it in your calculator. NPR, you'd say NPR, and it'd be what?
526 4.
Okay, let's see if that's the same thing. It's a good test here. So, so we say 26. I'm going to put to the 4th power rather than retyping it.
Okay.
That's the same thing as NPR 26, 4. It's not.
That's why I was confused.
Oh, that's okay. So it's not the same thing. So let me see if I can understand. So because with 26, 4, let's think about this.
Okay.
So that's saying, like, if you chose A as your first letter, for example, are you with me so far?
Yes.
26, 4, you cannot choose A again, right? You would have to choose B or C or D or some other letter next.
Okay.
Whereas using this, where you just figure out the number of combinations, because the letters can be repeated, this is the correct way of doing things.
Okay.
If the letters could not be repeated, then I would use NPR.
Okay.
So there's a slight difference between, you have to really think about, are letters being repeated or not? Because if you're ordering things, just think about the way ordering thing works. If there's 3 people in a race, right, you could choose, NPR and use that, but you're not repeating people. Like it's the same person can't finish first, second, and third. So NPR is good if you're ranking people or ranking letters or ranking whatever. But in this case, you're not really ranking letters. It's really, you've got a repeat, so you can repeat that same first letter. The answer could be AAAA. That would be amazing. You'd be the big winner. Because of that, you've got to do it this way. But then it'd be 1 out of whatever that big number was, the 457,000 or something. It'd be 1 over 456,976. And this would be 456,975 over 456. And then again, for expected value, you do these 2 plus those 2 multiplied.
Okay.
You type it in. What was the next one? Number 4 or 3?
Yes, number 3.
Oops. Okay. So when so you've got like, how many different outcomes could you have here? How could you figure that out?
Could you use slot method?
Sure can. And what would you multiply?
So there's 3 wheels and they spin it. So you just do 11 times 11 times 11?
Yep.
Okay.
And because numbers can be repeated there, that's the best way to do this.
Okay.
So you get 11 to the 3rd power, 1331. So when $1 is placed in the machine, the 3 wheels spin independently. the amount of the payouts. So again, you're making a little chart here,
Okay.
amount, probability.
Question about how you did that. So I know on one of we had a quiz where it would be like the probability of 3 something showing. So I tried using that method and it didn't work, and that's why I was confused.
Which question is this? Is this from like the homework or something?
I'm not sure, but I don't remember what the process is called. It's the one about
whether something's repeated or not.
I don't know. It was the one that was like the probability that she'll hit 2 arrows or something like that. So I tried to do the probability of 3 watermelons showing for the winning thing, and it didn't work.
Oh, I think I know what you're saying. So you use the binomial theorem.
I think so.
Okay, so let's see if that applies here. So with binomial theorem, you've got to have the same probability every time. You got to have a set number of trials.
Oh, so we don't have a set number of trials here?
I don't think we do.
Okay.
Like we're not getting 2 out of 5 tries or something. It just doesn't quite fit binomial, I don't think.
Okay.
It's kind of a different kind of situation. It's just I don't think it quite fits.
Okay.
Yeah, that's another hard one to recognize. One thing that's nice with the binomial is at least on the test, I kind of separate that out into a part there. You kind of know you're using, I give you the formula, I think.
Okay.
Just
So
like that
everything that we're given on the review
yes.
study guide
Yeah.
will have on the test.
Yeah, I think so. Any other questions?
Yeah, I'm sorry this has already been asked. I was a little late because I was like, we'll just try this problem again in the morning. And then I
Okay.
forgot about it until 9:30. So on number 11, this has happened to me on a few different problems, but every problem where you do NCR, we do the same thing and then we get completely different answers numerically. So I don't know if I'm doing something wrong.
Yeah, that's right. Okay, so if you want to get 5 different toppings, how many ways can you choose? So the big question you have to ask on this is order important or not?
No.
So order is not important. So what method do we have available? There's really only one method.
Oh, slot.
No. So
Oh,
here's what you need to get.
That's where I messed up.
NCR, NPR. Those are the 2 methods we have for this kind of question. And then slot is the same as NPR. That's when order is important. You can use slot. So you cannot use slot method when order is not important. So this is an NCR question, 25,5, and you'll get your answer right every time. Slot method will not work. That means order is important.
So when I was doing that problem, I did menu 5, 2, 25, 5.
So menu 5, 2 permutations. It should be combination.
Okay. And okay. That
And then
would, yeah.
25,5.
Yeah. Okay. Thank you. Also, Willow told me to tell you hi. She says she's
okay.
sorry she isn't here, but she is music theory.
Oh, nice. Other questions? Do you have other questions?
I do not. Thank you.
Oh, sorry. Can you go back to number 1 on the quiz?
Sure. Yes.
Okay, I'm just confused on like how you got like for your probabilities. Like I don't understand how you put like 1 over like that big number.
Okay. If you go back to this. This one?
Yes.
Yeah. So you have to find out how many possible passwords there are. So I did 26 times 26 times 26 times 26, which is this huge number on the calculator, 456,970.
Oh.
So that's how many possible combinations there are. How many winning
Okay.
combinations are there?
1.
There's only one, so that's why I put 1 in the numerator and I put that big number in the denominator. And over here for the
Okay.
losing, you could write it this way if this makes more sense to you. The denominator is still the same, 456,976. If this makes more sense to you, you can do 456,976 minus 1 in the numerator. The rest of the combinations, I did one less. Do you see how that's a 5 instead of a 6 there? There's winning combinations, so
Yes.
all the rest of the combinations are losing ones.
Okay.
So they have to add up
Do you
every
like
time.
when?
Yeah.
Okay. See, what I was doing was like, because there's like 26 letters, I did the probability was 4/26. Am I not supposed to do that?
Yeah, because it's a 4-letter password. If it's a 1-letter password, which would be, by the way, amazing, because you'd have a 1 in 26 chance of winning $400,000. That would be the case, but this is a 4-letter password, so that's why you had to do slot method and multiply
Okay.
26 times 26. You did the case of a 1-letter password. Like,
Okay.
that would be amazing. I would love to have the odds of, 1 out of 26 times I'd play the game, I'm going to win $400,000. That'd be amazing. But it'd be a pretty easy password to crack. I mean, your chances are good. 4-letter password, it's not as easy. It's going to take me a while to crack a 4-letter password.
Okay.
Other questions? Y'all good?
Just checking. We do not have to memorize any equations, right?
Nope, you don't.
Okay.
Okay. If you think of something later, just email me. I could help you out if you want to before tomorrow. Tomorrow, though, you're on your own. So thanks for coming. Appreciate it. Have a good day.